And you'll have to help me. I can't remember where we ended. So how far did we get? Noah, put it down. Put it down. Noah, put it down. Who remembers where we ended? We're ready for number 5? Okay, so we're ready for question 5. So here we go. So remember our little formula. S, remember, is arc length. So I remember, as I told you yesterday, arc length equals radius times radians. But formally, like in the textbook, it would say this, and it doesn't matter which way you remember it. It's just critical, however, that you remember in order to use this formula, theta has to be in radians. Okay? So let's see what we've got. Problem A. We have the radius is 6 and the arc is 10, and I need to find this central angle right here. Okay, so what's my formula say? Arc length equals radius times radians. Remember, if you don't like the Greek letter theta, you can certainly replace that with whatever variable you want, like an x or something. It's a variable. So 10 over 6, which reduces to 5 over 3. So the answer to question A in number 5 is simply 5/3. Now, B is going to be a little bit harder because in question B, the radius is 10 and the angle is 30 degrees and we need the arc length. So, you remember, I just said it and it's up here. If you remember the way I remember, then it's very clear the angle has to be in radians. So, who remembers how we change 30 degrees in radians? I over 180 equals x over 30. That's exactly right. Hopefully you're taking some good, some good stuff here because it's a long time till we get back to this. So 180x equals 30 pi, if I just cross multiply. And then divide by 180. And then always reduce. So I can cancel out the zeros. What have I got then? 165 pi over 6. Now, that is not the answer. All that is the angle now in radians. So then we can go back and actually find the answer. So arc length equals radius times radians. This is 10 over 1. We're going to multiply, so we're going to go straight across. So we get 10 pi over 6, which reduces to 5 pi over 3. Now, in this problem, the radius was 10 feet. So the arc length will be 5 pi over 3 feet. That is a unit of length, and so is this a unit of length, and they're always going to match. Okay? All right, and finally, draw a sketch of the path of a ship who travels 18.5 miles on a course of 110 degrees. So, here's my compass, north, south, east, and west. Here are my numbers, my angle measurements for those directions. Now, where am I going to put 110 degrees? Well, here's 0, and here's 90, and here's 180. So So isn't 110 gonna be somewhere in here like this? So we're just approximating it, it doesn't have to be perfect, but you're gonna mark this 110 degrees, just like that. And you're gonna mark this 18.5.
Tyler Walker to the front office, please, for an early dismissal.
Okay, we're good. Everybody okay with that? All right. Now, if you were here yesterday and
Amari
today,
Ford to the front office for an early dismissal. Trent Adams to the front office for an early dismissal. Allison Boyfield to the front office for an early dismissal. Robbie Blackwell to the front office for an early dismissal.
okay,
Ethan and Eli Shepherd to the front office for an early dismissal.
so if you were here yesterday and today, you do not need to turn in that homework. You'll get automatic credit. If you were not here yesterday, you'll need to complete it and get it turned in, okay? All right. All right, so now we're gonna set all that aside, and we're gonna get out our mini review. Now, please do not get rid of that. I need you to keep that material with you when you come to class, okay? Have that material with you. Don't put it somewhere, keep it with you. But now I need you to get out your exam mini review. Exam mini review. That is the single page paper. All right, and let's see if we can get this done. That would be great if we could get this paper done.
I need Sydney Smith to the front office for an early dismissal.
Okay.
Viviana Aguilera to the front office for an early dismissal.
Okay, so here we go. We're gonna do this division that says find the remainder. Okay, so what are we gonna do? This, remember, we talked about this yesterday. How's it work in this class? If it's on the review, it's on the test. That's right. If it's not on the review, it's not on the test. So, we should be paying really close attention and practicing, right? I know we're all a little distracted. Everything's fine. Time to get back to what we need to get back to. All right? So, what are you going to do here? We're going to use synthetic division. Now, you could do long division, but we didn't do very much of that, and it takes more space and longer, so I'm going to use synthetic division. What's going to go in box? -2. Across the top, I'm going to write 4, -8, 5, and -2. What do I have to be careful of as I'm writing down those numbers? That nothing's being skipped. Because if something's being skipped, I have to put in a 0. But nothing's being skipped, so we're all set. The 4 drops straight down, and now we're ready to multiply. -2 times 4 is -8. -2 times -16 is 32. And -2 times 37 is -74. So what was the question? Find the remainder. So the remainder is -76. Easy. Easy. Find the y-intercept. Okay, so stop and think now. Whatever the shape is, it doesn't even matter. You know, whatever the shape is. The y-intercept is the point where we touch the y-axis, right? So without even knowing an equation or anything, this is totally made up. What can you tell me about that point? X is 0. To find a y-intercept, you simply let x be 0. So, for question A, I am going to plug in 0. Now, some of you will let yourselves get psyched out by that weird looking equation that's called the logistic function. That's one of our BFFs. But it doesn't matter because anything to the 0 power is 1. So we have 14 over 1 plus 3 times 1. This is just 1. This right here is 1. Well, what's 1 plus 3 times 1? What's that? 4. And always reduce, so what's 14 over 4?
2 over 7. I'm 7 over 2.
7 over 2. 7 halves. Look, now we got another one. But again, it doesn't matter what the equation is. Okay? It doesn't matter. If you're finding a y-intercept, you are going to put in 0 for x. Okay, now do the math. So what's 0 plus 3? 3 squared, so this is 9. What's 0 minus 2? Negative 2. Timesing them together is going to give me negative 18. So, what's your y-intercept? Negative 18. Easy, easy, easy. How do you find the y-intercept? You let x be 0. Okay. Now we've got some quadratic function here. And we are going to let x be x minus 1. We're replacing x with x minus 1. So that means that that x right there becomes x minus 1. That is being squared. This x is also x minus 1. So we take out the x, put in x minus 1, take out the x, put in x minus 1, and now we got to do the arithmetic. So, what am I going to do first here? What's going to happen here? Yeah, I got to FOIL this. This is a FOIL. FOIL. It's x minus 1 times x minus 1. I'm going to FOIL that. So x minus 1 times x minus 1. What is that? X squared minus x minus x plus 1. So that is x squared minus 2x plus 1. And I still need to distribute that 3, so if I do that, I'll have 3x squared minus 6x plus 3. Okay, but don't forget, that's just this part, right? I still have plus 9x minus 9 minus 2. So let's collect my terms. It looks like I got 3x squared. Plus 3x. Minus 8. And that's it. Don't do anything else. That's the answer. That's the answer. Don't do anything else to it. All right. Find the inverse. that means we're looking for this. That means the inverse. So who remembers the steps to do this? Hey Joseph, let's move you up here next to Josh. So you can get a little closer. Okay, so who remembers any steps here? Anybody remember any of these? Izzy?
Do you multiply by -6?
No. No. There's a step I need to do first. Diego?
Excuse interruption, teachers. Please keep students in your classroom right now. We will dismiss at our normal time unless students have an early dismissal class. Thank you for keeping students safe in your classroom. We will be sharing more information as we have it. Again, thank you very much. You guys did an amazing job today.
I was planning on walking out, yeah. Couple more minutes.
No, when we do, what did you say, Diego? I'm sorry, you got interrupted. What were you saying? You gotta switch your variables, guys. When you find an inverse, you gotta switch your variables. So remember, the f of x is the same as y. So I'm going to start by saying x equals 2y minus 1 over 6. That's how we find an inverse. So step 1, very critical step, change your variables. Then, Izzy, we're going to start solving for y. So I would just times by regular 6. So 6x equals 2y minus 1. And then what? No, guys, I'm trying to get y by itself, so I'm going to add 1. So 6x plus 1 equals 2y. I'm getting y by itself. So I multiply by 6, add 1, and now I have to divide by 2. So my answer if I use my inverse notation is 6x plus 1 over 2.
Oh, you don't put like, okay.
Huh? Yes, you're inverting. Yeah, you're doing the same opposite operations in opposite order. Okay. Next, find the vertex of this thing. Now, there are lots of things that should be going through your mind right now about this problem, not about other things. This is a quadratic, which means its shape is a parabola. Parabolas are quadratics, x squared. And because it's a parabola, by the way, opening up, it has a vertex. The vertex is a point, and we're going to find that point. Does anybody remember how we did that? No. Could we use a calculator to find the vertex? Absolutely. Your calculator will find the minimum. This is a no calculator problem. So it has something to do with A, B, and C. Actually, it only has to do with A and B because our formula is x equals negative b over 2a. X equals negative b over 2a. Now, gang, the purpose of review is to jog your memory. Okay? Your exam's not for a few more days. You gotta review this and practice it and practice it. Okay, so in my equation, Negative b would be positive 6. And 2a would be 6. So it looks like my x coordinate is 1. Remember, the formula gives you your x coordinate. Then how do we find the y? Plug it into the problem. Now, we're gonna have kids make mistakes here because they forget their order of operation. When you look at this right here, what do I do first? Square 1. So what's 1 squared? 1. Then I times by 3. So this is 3. Minus 6 plus 1. What is that? Negative 2. So your vertex is at 1, comma, negative 2. So I want you to notice something here, gang. Problems 3 and 5 and 6 all look the same in terms of the equation, but they're asking different questions. This one says solve. So in other words, ultimately I want to know what does x equal. X equals. So what are we going to do? What? Quadratic formula? Will the quadratic formula always work on a quadratic equation?
Yes.
Yep. Anybody have any other thoughts? We could factor, except this one doesn't. So, always possibility, but it doesn't always work. The quadratic formula will work all the time. So, here we go. You tell me, I got it memorized. Do you? Negative b, so that'll be 3, plus or minus the square root of b squared, which will be 9, minus 4 times 2 times 5, all over 2a. Which would be 4. So, it is now December. If you still don't have the quadratic formula memorized, please do so. Okay, that you need to know. All right, so what's happening here? X equals 3 plus or minus what? 9 minus 40? Negative 31. Uh-oh, what does that mean? Well, the good news is 31 does not break down, so you don't have to worry about that. But the bad news is it's negative, so we have to pull out an I. Kind of the luck of the draw. When I make up a problem, sometimes this simplifies, sometimes it doesn't. 31 doesn't. It certainly could be that you have to simplify. All right, now number 7 is really recent. We should do a good job with number 7. So your job is to write this as one logarithm. Remember, ln is a logarithm. It is a log base E. So we need to put all this together in here. All right, so what do you want to do? 7 times q. And why is he timesing those? Because that's a plus. Square the q, where did that come from? That guy right there is a power on q perfect. And then over c. And why is that over? Because that's a minus, so we're gonna divide by that. Done. 8 is also recent material. What are we gonna do with problem 8? Log roll it. One of my students said the other day, unlog it, and really that's what we want to do. We want to remove the logarithm, and so to remove the logarithm, we say 4 to the second equals x plus 5. So 16 equals x plus 5, and it looks like our answer is 11. That's easy. I don't know, I'm gonna say that's a 2 on the end of there. I really don't know what it is. Let's just make it a 2 on the end of problem 9. And we are gonna list the possible rational roots, which we refer to as PRRs. We're gonna list the PRRs. All right, and what are they? Who remembers that? Plus or minus? Don't forget the plus or minus, guys. Okay? That's half. You only put in a plus, you're gonna miss half. All right, so here we go. Plus or minus what?
1 and 2.
Factors of 2 over factors of 3. So all of the factors of the last number, which I just said is 2 because I can't read it, over all of the factors of the first number, which is 3. So what you're going to put in the answer blank is the actual list. You're going to list them. So you're going to have plus or minus 2 and 1. And then you're going to have plus or minus 2/3 and 1/3. So we have 2 over 1 and 1 over 1, and then 2 over 3 and 1 over 3. And that's all of them. Factors of last number over factors of first number. Alright, consider, oh wow. Consider the square root function. Alright, BFF time. BFFs, here we go. What's the square root look like? Exactly, Kaylee, good job. She air drew it for me, it looks like that. That's the square root function. Okay, so step 1 of doing this problem is to remember what the function looks like, okay? I don't know if you still have your BFF cards or not. Hopefully you do to review them. If not, they are in your textbook, and certainly we did our BFF paper like this. Hopefully you still have that. If not, I guess you're gonna have to go back and watch the videos and get yourself up to speed. Okay, what am I doing here? Domain and range. All right, tell me about the x's. What can you tell me about the x's in this problem? The x's start at 0 and go to infinity. So there it is. There's your domain. Tell me about your range. That's the y's. Tell me about the y's. It's the same thing, isn't it? Aren't your y's starting at 0 and going up? Yep, so your domain and range happen to be the same. That's not the case for a lot of them, but it is for this one. How about zeros? What do we mean by zeros? X-intercepts. So does the square root function have an x-intercept? Does it touch the x-axis anywhere? It does. Its zeros are the origin right there. That's where it touches the x-axis. If you had something like your exponential function, the exponential does not have any x-intercepts. Okay, that's your x-intercept. What about your y-intercept? Same thing. Yep, it's the origin. This kind of a boring function. Would you say that function is increasing or decreasing? Increasing, because what's happening as you draw it? You're going up. How about the exponential? What would you say about it?
Up.
Increasing also? Yeah. Does this, the square root function, does it have any asymptotes? No. This one has an asymptote. Asymptotes are things that you get closer to. You don't have that in this situation at all, so there's no asymptotes there. And bounded means ceiling and floor. Does this one have a floor? That is a bottom. Yes. Below, it has a floor. It has a floor. Does it have a ceiling? No. It just keeps going up, 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 up forever and ever. So bounded below, but not above. Bounded below, not above. Look at this one. This is the same thing. Would you say this one's bounded below? Does it have a floor? Yeah. It doesn't touch it, but it's still getting closer and closer to it. But no bound above, because that just shoots up forever and ever. All right. Now, the reason there's a line across there is because that designates now I need a calculator. So all of these things I didn't need a calculator for, but I do need a calculator for problem number 11. In fact, the rest of the sheet I'm going to need a calculator for. I had to have that one and I couldn't remember where I put it. Okay, help me. Who remembers how we solved something like this? I'm going to take the natural logarithm of both sides. Oh, wait. There we go. Take the natural logarithm of both sides. What good does that do? That's gone. So 3x plus 4 equals ln 11. Now remember, you're solving for x. So what are we going to have to do? Subtract the 4. And then divide by 3. All right, so let's type this in, make sure we can. So ln 11, close parentheses, minus 4 equals divided by 3. This one's a little tricky. You have to put in your whole numerator and your equals, and then divided by 3. Did you get negative 0.534? That's what you need to get. So type it in until you get that. So ln 11, close parentheses, minus 4 equals divided by 3. Everybody good? Okay. Dang, stay awake, honey. Are you sick? Okay. Type in with us. All right, number 12. how long will it take 123 bacteria to grow into 576 if the growth constant is 11.2%? Now, you need a formula. Oh yeah, I don't even need to write this one. Everybody knows it's PERT. You're right, it is. It's PERT. So here we go.
There's not enough room.
What's the 123? That, no.
Pete,
That's what I start with. I'm starting with 123. What am I ending with? 567. What's my R? 0.112. 11.2. Izzy, 2 places. 0.112. And T is the thing that I don't know. Step 1. Not gonna take a logarithm yet. What do I have to do first? I gotta divide by the 123.
divide by 123.
Please don't type that in, because if you round it off, you're gonna be off. I don't want you to round that off. So there's your fraction. Okay, fine. What do I do now? Now it's like this one over here. I'm gonna ln both sides. And the beauty of that is gone. So ln 567 over 123 equals 0.112t. And I have to divide by the 0.112. And you better get a positive number this time. No negative time. Tell me what you came up with. T is what? 13.644 days. How do I know it's days? Because the problem says it's per day. Okay, so it's days. Type that back in. Make sure you're getting 13.644. All right. Now, on the back, our good old box problem. We're going to take a piece of paper that's 20 by 14, and we're going to cut out corners that are square. Remember, you actually did this one day? You made a box by ripping out little squares from the corners and then folding up the flaps. And we noticed that although everybody started with pretty much the same sheet of paper, all the boxes were different sizes and shapes because everybody was taking out different size corners. So your job is to take out the corner that's going to maximize the volume of your box. So, who remembers how we write the equation for the volume? Who remembers anything about the volume of a box?
Length on this side.
Okay, so the basic formula is length times width times height from geometry. But we are doing it for this particular box. So what is its length? What's the length of this box? Well, the length of the paper is 20. This is 20. But this is the length of the box, the actual box. So what's that?
20 minus
2x.
20 minus 2x. Because you took this piece of paper and you cut an X off here and an X off here so that you could fold that flap up. Alright, what's the width of this box?
14 minus 2x.
14 minus 2x. Because you did the same thing with the 14. You took off an X here and an X here so that you could fold up that flap. What's the height of this box? I heard somebody say it. It's X. The height of the box is X because, guys, when you fold up these flaps, isn't this height here going to be X? Isn't that how tall those flaps are going to be? So that's your volume. That's the volume of the box. Okay? Now, what's the domain? That's the second question. What's the domain? So you need a minimum X and a maximum X. Number. These are numbers. So what's your minimum X? What's the smallest X could be? Somebody said 1. Could it be 1/2?
Yeah, no, but
X can be anything as long as it is positive. So your minimum X is 0. What's our maximum X? I heard somebody say it, I think. 7? Why is it 7? You're right. Why is the maximum X 7? It's half the smallest dimension. That's my domain. Half the smaller of these two numbers. Okay? Now, I gotta find the maximum I gotta maximize the volume. So, I'm gonna need my calculator, my graphing calculator. I'm gonna go to my window, Joshua, go to window, and X min is 0, X max is 7. That's what you figured out right here. These are your domain, these are your X's. Okay? Kaylee, where's your grapher? Get it out. Before I write you up.
What?
We're graphing. Maya, where's your calculator? Get it out. I'm using it. So our domain, or excuse me, our X min is 0. Our X max is. You two gotta get.
2.7?
Yeah, good points again. Well, hurry
What's
up.
our X min?
Zero.
I mean, our Y
X
min.
min 0, X
just
max
keep it
7. What's Y min? What's your minimum volume? 0. Always. You can't have a negative volume, so your Y min is going to be 0. And then do you remember that Y max is the number we just kind of guessed? So 800, somebody said, I'll just use 800. All right? Then I go to Y equals, I got it all set up now, so I go to Y equals and type in my equation. You can type it right in with the parentheses. Yeah, you find it?
10?
Too late. Yeah, you should have had it out earlier. We've been typing in problems. And then as soon as you get your equation in, hit graph. Now, what is the only requirement? You have to see the top of your hill. So I see it, so it's okay. But do you remember that there are some times when we don't see it? Because our guess, we guessed 800, sometimes that guess is too low. So we have to try again with a higher number, but we're good this time. So then we second calc maximum. We arrow over, so we're setting a left bound. Press enter. Arrow over to get your right bound. Press enter. And then our maximum, which is 2.704, comma, 339.013.
Good afternoon, Cathedral. Before we play the end of the day, this is Dr. Bridges here. I just want to thank you all for your attention to the details and understand the importance of why we practice these drills for our safety. It's a great job by the adults and students as well. So thank